Hello, good evening, everyone. Welcome to these solutions. Oh my God, I forgot to write this here. Do you want me to write? Okay. अरे लिखना यार. Solutions for the physics homework for IVDP. Okay. This is my eighth video, I think. Yes. This is the eighth video, solutions for the eighth video. Uh, Yesterday I had uploaded the eighth video. I think I uploaded it a bit late. I thought I had already uploaded, but unfortunately it didn't get uploaded. So hence yesterday I made it up. By night, I think around 10:45, 11, I was just viewing it. And then I observed this was not done. So I just put it across. I think it would have got published by 11 o'clock yesterday night. Okay, so now let us begin with it. So we are going to find out the solutions for this. Now, the first question. A toy car of mass 0.15 kg mass is given. Starts from a speed of, accelerates from a speed of 10 centimeter. U is given because starts from, and then 2 year speed of 15. V is given. What is the impulse acting on the car? What is impulse? Impulse is nothing but change in momentum. Change in momentum. Or this is also defined by F into T. F into delta T, not T, F into delta T. Force multiplied by delta T. That's the reason why you see you have millinewton and second as a unit. Okay. Now let us work with this. So change in momentum means what? It is m into v minus u, right? So what is m? 0.15 multiplied by 0.15 into v, 15 minus u, 10, okay, which will be equal to 0.15 into 5 centimeter per second kg. Units are very important. If you do not write the units, you will lose marks. So 5 into 0.15 is 0.75, 0.75 kg centimeter per second. But what is being asked? Don't just directly mark this one. Okay, let us find out what is the correct one. So this should be 0.75 because you see this is Newton second. Okay, I need to convert this to meters. Kg. Sorry, this is meter per centimeter per second square here. Centimeters, second only, sorry. Putting it correctly. Kg centimeter per second. That's right. Okay. Now kg. And then this one I'll write this as 10 power minus 2 meter per second. Now what I will do is I'll write this as 0.75. I'll make it as 7.5 into 10 power minus 3 kg meter per second. But you want in terms of Newton second. So what I will do is I can now write this as 7.5 into 10 power 3 kg meter per second square into second. What is this acceleration? What is this mass? So therefore, you get this as 7.5 into 10 to the power of 10 to the power of minus 3. That's a negative sign here. 10 power minus 3 Newton into second, which should be 7.5 into 10 power of minus 3. Sorry, not 10 power minus 3. 7.5 millinewton second. So answer is answer A. Most of you had written this one, so it is incorrect. Then a student measures the radius r of a sphere with observed uncertainty delta r. What is the fractional uncertainty? Today only I did the same thing in the class. So in the volume of the sphere, volume is given by 4 by 3 pi r cube, right? And then what is he asking? Fractional uncertainty in the volume, which means what? I want delta v by v, right? Delta v by v is equal to what? So v should be equal to 4 by 3 pi r cube. Delta v by v should now be equal to, this is constant, this is constant, this is constant. Or if you want, I can just say delta of 4 by 3 plus delta of pi plus delta of r cube. When I do this, this delta becomes 0, this becomes 0, and we are left out only with this, which should be 3 times delta r by r, right? What is delta r? 3 times delta r by r, which is nothing but your answer B. So answer B. Okay, delta v by v. Fractional uncertainty is asked. So this is the right answer. Next, an object is projected vertically upwards at t equal to 0. Start from here at t equal to 0. Here this is negligible. The object passes the same point above its starting points at times 2 seconds and 8 seconds. You throw it It goes like this, reaches to a maximum extent, then comes back like this. That is known to us. Now he says the particle passes the same point, let us say at this point, at 2 seconds and 8 seconds. The time taken by the particle to start from here and to go here is 2 seconds. And once again, it keeps on going and finally it returns back and reaches the point at 8 seconds over here. Which means now what we need to do is, he is asking you what is the initial speed of the object, is what speed it is. Okay. Now, some of you would have been done by some methods, but the most easiest method, which I would prefer to do is, if this is 2 seconds, this is 8 seconds, we know that time up should be equal to time down, right? So therefore, now here, at what time does it reach here? That's what you need to look at. So this will reach exactly at 5 seconds. How do I know? Take the average, 2 plus 8 divided by 2, right? Or maybe here you say I have counted 3 here, reduced 3. So therefore, it becomes 5 seconds. Now, what is 5 seconds over here? Time up, right? The particle takes a time 5 seconds to reach to the maximum height. So therefore, we know that the time of flight is given by 2uy divided by g. This should be 2u by g, because sine 90. So which is equal to 2u by g. This is what, time 2u by g. Now, when you say t up, this should be equal to t by 2. We should just be equal to u by g. What is the time taken now here? Starting from here to here, how much did it take? 5 seconds. 5 should be equal to u by g. Substituting u is equal to 5g, which is equal to 5 into 10, which should be 50 meter per second. So the answer is U. Okay. Next, let us move on to the next one. Uniform ladder resting in equilibrium on rough ground leans against a smooth wall. So this wall is smooth. You have to make a note of this. Okay. Which diagram shows the forces correctly acting on the ladder? When you read this one, leans against a smooth wall, which means this is a smooth wall. See, this one here. So in all these 4 diagrams, there should not be any friction, which means this is incorrect. This is also incorrect. But in a horizontal, he never says that. Okay. Now, if this doesn't have friction, now what all forces acting on here? Normal is acting here. Good. mg is acting outwards. This normal is acting here. So this is fine. Now, what is the possibility? Now, you see, this ladder cannot automatically go like this. If possible, it can slide down like this. It can slide down, which means after some time might be, okay, this ladder would be here and this would be like this over here. Okay, it could be like this. So there's no friction here. Now, how does the friction act? When this part of the rod is now moving like this, then definitely friction should try to oppose it. It should act like this. Which one is the right one? D. B is the right one. Okay, next. Finally, an object moves from a height h close to the surface of the moon. Okay, an object from rest falls. This is the moon. Then this is my height h. You are dropping something from the surface of the moon. The moon has no atmosphere. When the object has fallen to a height h by 4 above the surface. When the object has fallen to a height h by 4, from here you are going to drop. From here you are going to drop. So as a result of it, at a height h by 4, this height is h by 4. What is the kinetic energy of the object as h by 4? Okay, so this height is h by 4. So as a result of it, it has described a distance of 3h by 4 downwards, right? And hence, its potential energy here was mgh. Here it is mgh by 4, 3 mgh by 4, right? No, just mgh by 4, mgh by 4. Okay, so this is a potential energy. And as we know, kinetic energy plus potential energy equal to total energy, right? Kinetic energy plus potential energy is equal to total energy. Total energy here was mgh. And here it is kinetic energy plus, what is the potential energy at this point? mgh by 4. Thus, the kinetic energy here will now be equal to 3 mgh by 4. Right? At this point, the kinetic energy is 3 mgh by 4. Now, we have got the kinetic energy here. 3 mgh divided by 4 divided by potential energy of the object at h. What is the potential energy at this point? mgh. Now, this mgh and this mgh goes away. Thus, the answer is 3 by 4. So, answer is A. Okay, we have come to an end of the solution for the 5 problems. Thank you, friends, for watching this video until the end. And if you do like it, do share and subscribe to my channel for more updates. Thank you.